If I stretch a spring, what is its potential energy? What is the potential energy of a stretched spring? Well, we talked about the amount of work done in stretching a spring. What is the work that you need to do to stretch a spring? It will be 1/2 kx squared, is that right? And when you do an amount of work 1/2 kx squared, it gets stored in the spring as its potential energy. So potential energy of a stretched spring is 1/2 kx squared. That is an important information. We will be using it as we move on. Let's now talk about conservative and non-conservative forces. Another important concept in physics. Now, weight of an object is a measure of the gravitational force on it. Now, the gravitational force on the book is negative mg. Why do we call it negative mg? Gravitational force is directed downward. Now, the amount of force that you need to apply to lift it is positive. You apply it upward. But the gravitational force on the book, which is its weight, is negative mg, which is directed downward. Well, here again we have the book. Its weight is mg acting vertically down. Now remember, when we have indicated the direction as downward, you will not then use the negative sign. The negative sign simply tells you that that force is directed down. Now, what is the work done by the gravitational force when the book is raised through a height h? Now, you must distinguish between the work done by the applied force. What we did in the previous slide is to calculate the work done by the applied force in racing through a height h. And that is F times h, where F equal to mg. Okay, now tell me, if negative mg is the weight of the book, which is the gravitational force on the book, what is the work done by that gravitational force when you raise the book through a height h? When you raise the book through a height h, this gravitational force, which is negative mg, has been moved through a height h, or negative mg is displaced by h meter. Therefore, work done by gravity on the book is negative mgh. The work done by the applied force on the book is positive mgh. But the work done by the force of gravity on the book is negative mgh. Now, if you allow the book to fall, this gravitational force, negative mg, will be displaced by negative h. Is that right? Yes. When the book is now allowed to fall, well, here is my book. If now the book is allowed to fall, this negative mg is going to be displaced through a distance negative h. Displacement is downward. There you are. It's negative h. So what is the work done by gravity in this case? The force negative mg has been displaced by negative h. Therefore, the work done in this case will be negative mg times negative h, which is positive mgh. Well, one more time. The work done by the force of gravity when the book is raised up through a height h is negative mgh. Alright? When the book is allowed to fall, the gravitational force negative mg is displaced through a distance negative h. Therefore, the work done during that time is negative mg times negative h, that is positive mgh. Therefore, what is the total work done by the force of gravity for the entire trip? The work done by the force of gravity in raising the book is negative mgh, and the work done by the force of gravity while the book is falling through the same height is positive mgh. Therefore, the total work done for the entire trip is negative mgh plus mgh equal to 0. Now, this is a very important concept. I want you to understand this because we're going to use it here and also in the next semester physics. Very important. A force is conservative if the total work it does on the object is 0 when the object is moved around in a closed path. Now, what is the meaning of a closed path? Suppose this is the beginning. I raise the object through a height h and leave it. The force of gravity, I'm not talking about the work done by the force I applied. I'm talking about the work done by the force of gravity. The work done by the force of gravity for the first part of the journey is negative mgh. While the object is allowed to fall, the work done by the force of gravity is positive mgh. The total work done is 0. So, a conservative force is a type of force where the total work done in a closed path is 0. Now, therefore, we say the force of gravity is a conservative force. Now, can you think of any other force which is a conservative force? Well, when I stretch a spring, you know that the spring will pull me back. Just like when I lift an object, the earth will pull it back. When I stretch a spring, the spring will pull me back. And the force applied by the spring is called the restoring force of the spring. Now, the restoring force of the spring is a conservative force. The work the restoring force does while I stretch it is negative. When I let it go, the work it does is positive. The total work done in a closed path is 0. And that is the definition of a conservative force. So gravitational force is a conservative force. The restoring force of a spring is a conservative force. Well, if the gravitational force is a conservative force, the restoring force of a spring is a conservative force, can you give me an example of a non-conservative force? Is there an example for a non-conservative force? Now, think of a surface moving on another surface in a closed path. And one of the forces involved in here is the force of friction. Is the work done when the object is moved in a closed path by the force of friction 0 in this case? No. The work done when the work done by the force of friction when the object is moved in a closed path is not 0. Therefore, force of friction is a good example of a non-conservative force. So you must be able to distinguish between a conservative force and a non-conservative force. Well, good examples of conservative forces are gravitational force and the restoring force of a spring. And a good example for a non-conservative force is the force of friction. Let's look at the restoring force of a spring. When a spring is compressed by a force F, the spring applies a force in the opposite direction, and it is that force that we call the restoring force. So when you try to compress the spring, applying a force towards the right, the spring will apply a force in the opposite direction, and that is what we call the restoring force. Now, the work done by the restoring force, if now the spring is compressed by a distance x, the work done by this restoring force, which is negative F, will be negative F times x, and you know that will be 1/2 kx squared. So work done by the restoring force of the spring is negative 1/2 kx squared. Now, once the spring is compressed, if you now remove the external force, what will happen? The spring will jump back, or the restoring force will now restore the spring to its original position. Now, the amount of work done what will be the amount of work done at that time? The amount of work done to compress the spring by a distance x, the work done by this force, that means the force applied by the spring called the restoring force. The work done by the restoring force is negative 1/2 kx squared. When the applied force is removed, the restoring force stretches the spring back to its initial position, doing an amount of work, how much? W equal to 1/2 kx squared. So while compressing, the work done by the restoring force is negative 1/2 kx squared. When the external force is removed, the work done by the restoring force is positive 1/2 kx squared. Therefore, the total work done by the restoring force is negative 1/2 kx squared plus 1/2 kx squared equal to 0, which indicates that the restoring force of a spring is a conservative force. I want you to pay special attention